I'm also really fascinated by the role of genetics. And here is an article looking at epigenetic status of a region of the human MMP11 gene promoter. And they found that it is altered in patellar tendinopathy. Now, this is a sports and specifically like a sports physical therapy or sports medicine example, but what can we potentially learn about individuals who are at risk for disease based upon their genetic potential? Now, who develops jumper's knee? That's patellar tendinopathy. It's people who jump. So, do all people who jump develop jumper's knee? No, of course not. But what's interesting is there may be a genetic predisposition for developing jumper's knee, and it's only manifested then in those individuals who have that genetic predisposition and who play a sport like basketball or volleyball. Really fascinating stuff. How that applies to other diseases or other injuries, I think only time will tell. Now, let's look at population dose. In epi studies of cancer caused by environmental or occupational factors, another way of presenting group dose is sometimes used. So this is the dose commitment or population dose. It's calculated as the sum of individual doses. It's based on fundamental assumption that there is no threshold individual dose below which the cancer risk is zero and the cancer risk increases with dose. For many environmental factors, effects range from subtle physiological or biochemical changes to severe illness or death. Usually, the higher the dose, the more severe or intense the effect. This relationship between dose and severity of effect in the individual is called the dose-effect relationship. And this figure illustrates this dose-effect relationship looking at carboxyhemoglobin in the blood, and as the percentage increases, we progress from maybe minor symptoms like a headache to ultimately death. Now, the dose-effect relationship provides valuable information for the planning of epidemiologic studies. Some effects may be easier to measure than others, and some may be of particular significance for public health. Measurements of changes in biomarkers may be used to study early subtle effects as well as the exposure. Response is defined in EPI as the proportion of an exposed group that develops a specific effect. Shape of the relationship looks like an S. At low doses, almost nobody suffers the effect, but at high doses, everyone does. Here's an example looking at that S shape with traffic crash injuries and the probability of death, where at lower speeds down here, probability of death is very low. It starts to rise as speed increases, and as speed gets to a higher point, the probability of death is almost 100%. Same thing can be said for other types of things such as workplace injuries, violence, and suicides. So again, with traffic crashes, as we mentioned before, there is that dose-response relationship looking at speed and also taking into account potentially drivers with and without seatbelts. Now, the work that's been done, the epidemiologic work that's been done looking at driving speed and seatbelts, these have led to preventative approaches, trying to improve survivability and reduce the negative impact upon society. Here is a figure from the text showing the relationship between driving speed, seatbelt youth, and the frequency of injury in drivers involved in collisions. And so, if we take a look here, non-fatal injuries not belted and non-fatal injuries belted, what are we seeing here? Well, we're seeing at a speed of maybe nearly 70 miles per hour. Non-fatal injuries here were at a lower level than the non-fatal injuries for those non-belted. So look at the frequency of injuries. So a greater percentage of injuries in those not belted than those who were belted. And these are just the non-fatal examples, not the fatal ones. Probably a much different presentation with that. Other workplace injuries, things like back pain in construction work or exploring chemical exposure in agricultural workers. Violence is another public health problem that's been highlighted through epidemiologic analyses. In some high-income countries, homicides are a major cause of death among young males. It can be even worse in some low and middle-income countries. Suicide, another cause of death. Environmental factors causing suicidal intent are primarily social or economic, but completed suicides are also dependent on access to methods, which can be viewed as an environmental factor. Okay, so this week you've got a forum post to do, and I want you to propose a research study and study design to assess risk in environmental or occupational setting. Please include the following: population and setting, length of study, and exposures. So here's an example. Cohort study, prospective cohort, looking at male migrant vineyard workers setting our vineyards in Washington and Yamhill counties in Oregon. Length of study 1 season from February through harvest. And then the measures that I'm going to collect are listed there. The exposures would be daily work exposures, collecting info on the jobs that they're doing at different times during the year. All right, there's also a homework assignment, and that'll be due next Sunday.